Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. So today we are going to continue for 4.2, which is the title is Functional Group and Homologous Series. So this is the learning outcome for this subtopic. The first one is define the functional group. Second, state the functional group of the following class of compound. Number 3, identify functional group in a given compound. Next, define the homologous series. And the last one is explain the general characteristic of the homologous series based on represented by a general formula, same functional group and chemical properties, gradual change in physical properties with increasing number of carbon atoms, and successive member of series differs by a CH2 group. Okay, so now we look at the definition of functional group. Functional group is an atom or group of atoms in an organic molecule which characterize the molecule and enable it to react in specific ways which determine its chemical properties. So this is the definition of functional group, which is the keyword is an atom or group of atoms characterize the molecule, okay, to determine its chemical properties. So functional groups are important because it is a basic by which organic compounds are divided into different classes. Alright, because in organic chemistry we can classify organic compound based on their homologous series, and then it is a basic for naming organic compound. And the last one, it is a particular functional group will always undergoes the similar type of chemical reaction, which is the molecule or compound which have the same functional group have the same chemical properties. A series of compounds with the same functional group or similar chemical properties in which members differ from one another by the additional CH2 group. So this is the definition of homologous series. Members of the same homologous series are called homolog. Okay, so member in the same homologous series we call as homolog. Example, we have homologous series for alcohol. So this is the member in alcohol homolog series, which is the first one is methanol with 1 carbon CH3OH, ethanol 2 carbon CH3 CH2OH, and propanol with 3 carbon atoms CH3 CH2 CH2OH. So these 3 compounds of alcohol, methanol, ethanol, propanol, are in the same homologous series, which is alcohol. All members of the series can be represented by the same general formula. So this is the characteristic of homologous series, which is all the members in the homologous series have the same general formula. Example, we have alkane, which is alkane. The formula is CnH2n plus 2, which is n is integer, which is starting from n equal to 1, 2, 3, and so on. So the members of alkane is ethene, example, with 2 carbon CH3 CH2, and then we have propene with 3 carbon atoms CH3 CH2 and CH3. So ethene and propene have the same general formula, with the formula is CnH2n plus 2. Okay, so the next example we have alcohol, which is the general formula is CnH2n plus 1 OH. Okay, so the first member in homologous series of alcohol is methanol, with the 1 carbon atom. Okay, so the formula is CH3OH, and then we have ethanol, 2 carbon atoms, CH3, CH2OH, and we have propanol with 3 carbon atom. The formula is CH3, CH2, CH2, and OH. So these 3 members, methanol, ethanol, and propanol, are in the same homologous series, which is they also have the same general formula, which is the formula is CnH2n plus 1 OH. All members of the series have the same functional group, thus have the same chemical properties and can be prepared by the same general method. Okay, so this is the characteristic of homologous series, which is members in the same functional group have the same chemical properties and can be prepared by the same general method. Okay, example for carboxylic acid, which is the functional group is COOH, carboxyl group. So we have ethanoic acid with 2 carbon atoms, CH3COOH. Propanoic acid, CH3, CH2, COOH, and then we have butanoic acid with the 4 carbon atom in the molecule, CH3, CH2, CH2, COOH. Okay, so if we look at the structure of these 3 compounds, ethanoic acid, propanoic acid, and butanoic acid have the same functional group, which is the functional group is COOH. Alright? Okay, so another example is functional group of alcohol, which is alcohol SOH group, which is hydroxyl group. Okay, so this is the members of alcohol. Okay, methanol with 1 carbon atom, so the formula is CH3OH, and then we have ethanol, 2 carbon atoms, so the formula is CH3CH2OH, and propanol with 3 carbon atoms, CH3, CH2, CH2OH. So methanol, ethanol, and propanol are in the same group, functional group, which is alcohol, and they have the same functional group, which is hydroxyl group. Okay, diverse homologous series is diverse from the successive homolog by a CH2 unit. Okay, so all members in the same homologous series has a different of CH2 unit. Okay, let's say we look at one example. Okay, functional group of carboxylic acid. Functional group of carboxylic acid, which is ethanoic acid, propanoic acid, and butanoic acid. So this is, if we refer to the structure, so ethanoic acid, propanoic acid, and butanoic acid are diverse by a CH2 unit. Alright, CH2 unit. And also goes to alcohol, which is methanol, ethanol, and propanol. If we look at for the structure, so each members are differ by a CH2 unit. Alright, so this is the characteristic of homologous series. Okay, so which is the members is diverse by a CH2 unit. Okay, the next one, okay, shows a gradual change in physical properties with the increasing number of carbon atom. So in functional group or homologous series, so each members have the different boiling point or different physical properties, which is the boiling point is increased by the decreasing of carbon atom. Alright? Okay, so as the molecular size increase, the intermolecular forces become stronger, thus the boiling and melting point increases. So if we go down to the homologous series, actually the number of carbon is increasing. So when number of carbon increasing, so the molecular size is also increased. Yeah, and then the intermolecular forces become stronger, then the boiling point or melting point increases. Okay, example, we have alkane. Okay, so this is the homologous series. The members of homologous series for alkane: pentane with the 5 carbon, which is the formula is CH3, CH2, 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 CH3. So 5 carbon atom in pentane. So the boiling point is 36. Alright, so the next members we have hexane. Hexane with 6 carbon atom in the compound, which is the formula is CH3, CH2, 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 CH2 and CH3. And then the boiling point is higher than pentane, which is the boiling point is 68 degrees Celsius. The next one, heptane. Heptane is 7 carbon atom in the compound. Okay, so this is the formula or the structure of heptane, which is, look at the boiling point. The boiling point is higher than hexane and pentane, yeah, because heptane has greater number of carbon compared to hexane and pentane. Yeah, and then heptane has a stronger van der Waals forces or stronger intermolecular forces, and then the boiling point is of heptane, yeah, is higher compared to hexane and pentane. Yes, so this is the characteristic of homologous series. Okay, so now we look at the important functional group of organic compound. Okay, now we have alkane, which is the functional group of alkane is none. Okay, and then general formula of alkane, so you need to memorize, which is the formula is CnH2n plus 2. So the IUPAC name for alkane, which is the nomenclature is ending with the word of N. Example, we have methane. Methane, 1 carbon, CH4. So the name of the compound is methane. Alright, A-N-E. So the N of the word is A-N-E. So this is the homologous series or the members of alkane. Okay, the second one we have alkene, which is alkene C double bond C. Yeah, so the name of the functional group is double bond. Alright, double bond, and the general formula is CnH2n. Alright, and then the IUPAC nomenclature is ending with the word of in. Right, E-N-E. Example for alkene is ethene. Okay, CH2 double bond CH2. Okay, so next we have alkyne. Alkyne, the functional group is triple bond. Yeah, so carbon has triple bond with carbon, and the general formula is CnH2n minus 2. And the IUPAC nomenclature of alkyne, so the nomenclature is ending with the word of "-ine". So, alright, Y-N-E. Example for alkyne is ethyne, yeah, with 2 carbon atoms, CH, ethyne. Okay, so this is important functional group of compound or homologous series that you need to memorize. Okay, so the next homologous series is Arin. Yeah, Arin is benzene ring. So this is the structure of benzene ring, which is a hexagon, yes, shape, and in this structure contain of 3 double bond. Alright, and then the general formula for Arin or benzene ring is CnH2n minus 2. Okay, and then the IUPAC name is benzene. Alright, so the nomenclature is ending with the word of benzene. Example, we have methyl benzene. Okay, so this is an example of homologous series for Arin. Alright, the next one we have alcohol. The functional group is OH. Yeah, the name is hydroxyl. Alright, the name of the functional group is hydroxyl. The general formula is CnH2n plus 1. OH. So this is the general formula. And then the IUPAC nomenclature is alcohol. Yeah, normally the nomenclature of alcohol is ending with the word of "ol". Okay, so example, we have ethanol, which is the formula is CH3 CH2OH. So the IUPAC nomenclature for this compound is ethanol. Alright, the next one we have ether. Ether have the same general formula with alcohol, but have different functional group. Alright, so functional group for ether is OR. So this is the structure, and the name is alkoxy. Alright, so this is the functional group of ether, alkoxy, and then the general formula is CnH2n plus 2O. Okay, so this is the general formula for ether, and the IUPAC nomenclature is alkoxyalkane. Alright, example for ether, we have CH3OCH3. So the name of the compound is methoxymethane. Okay, so this is the homologous series for ether. Next, we have haloalkane or alkyl halide. Alright, and then the functional group is X. X is referred to halogen, yeah, the element in group 17. For example, chlorine, bromine, iodine, and so on. Alright, so the general formula for haloalkane is CnH2n plus 1X, and then the IUPAC nomenclature is haloalkane. Alright, example for haloalkane or alkyl halide, we have CH3, CH2Cl. So since there are two carbon atom and then one chlorine atom here, so we call as a chloroethane. Alright, so this is the example for haloalkane. The next one we have aldehyde. Aldehyde. Alright, so this is the structure of the functional group. So this is bonded to either hydrogen or alkyl group. Alright, and then C double bond OH. So the name of the functional group is carbonyl. Alright, and then the general formula is CnH2nO, and then the IUPAC nomenclature is alkanal. Alright, so the nomenclature of aldehyde is ending with the word of al. Alright, okay, so next example for aldehyde, okay, CH3CHO. So this is the structure for carbonyl, functional group of carbonyl. So since there are two carbons, so the name is ethanal. Okay, the next one is ketone. Ketone have the same general formula with aldehyde. Yeah, and then the structure is same with aldehyde, and also the name of the functional group is carbonyl. The general formula is CnH2nO, and then the IUPAC nomenclature is alkanone, yeah, which is nomenclature for ketone is ending with the word of on. Alright, okay, so look at example for ketone. We have CH3, C double bond O, CH3. Alright, so this is different with aldehyde, which is aldehyde, C double bond O attached to hydrogen, but in ketone, the C double bond O is attached to alkyl group. Okay, example, methyl. Alright, so since there are three carbon atom, so the name of this ketone is propanone. Okay, propanone. Okay, so this is homologous series for ketone. Next, we have the carboxylic acid. So this is the structure for carboxyl. Yeah, the carboxyl group. Yeah, the name of the functional group is carboxyl. Okay, C double bond O, OH. And then the general formula is CnH2nO2. Okay, and then the IUPAC nomenclature is alkanoic acid. Yeah, so the nomenclature is ending with the word of acid. Example for carboxylic acid, we have CH3, C double bond O, OH. So there are two carbon atom in the carboxylic acid. So the name of this carboxylic acid is ethanoic acid. Okay, next we have acyl chloride. Acyl chloride, so the functional group, the structure of the functional group is C double bond O Cl. Alright, the name of the functional group is acyl. Okay, and then the general formula is CnH2n plus 1 COCl. Yeah, and then the IUPAC nomenclature is alkanoyl chloride. Okay, alkanoyl chloride. Okay, so the example for acyl chloride, we have 2 carbon here, CH3, C double bond OCl. So this is ethanol chloride. Okay, so this is functional group for acyl chloride. And the next one is ester. Ester, so this is the structure of functional group for ester, C double bond O, OC. So the name of the functional group is carboalkoxy. Okay, and then the general formula is CnH2nO2, and the IUPAC nomenclature is alkyl alkanoate. Yeah, so nomenclature for ester is ending with O1, O-A-T-E. Okay, so example for ester, we have CH3, COOCH3. Alright, so the name of the ester is ethyl ethanoate. Okay, ethyl ethanoate. Okay, the next one we have anhydride. Anhydride, so this is the structure of the functional group. C double bond O, OC double bond O, and the name of the functional group is anhydride. So there is no general formula for anhydride. Okay, and then the IUPAC nomenclature is anhydride, and then the example for anhydride, we have CH3, C double bond O, OC double bond O, CH3. So this is ethanoic anhydride. Okay, so ethanoic anhydride. Okay, and the next one we have amide. Okay, amide. The formula is CnH2n plus 1 CONH2. Alright, so this is the general formula, and the IUPAC nomenclature is amide. Okay, amide. And then the example for amide is CH3, C double bond O NH2. So this is the structure for functional group of carboxamide. The name of the compound is ethanamide. Okay, ethanamide. Okay, next we have nitrile. Okay, nitrile, C triple bond N. Alright, so the functional group, the name of the functional group is cyno. Alright, and then there is no general formula for nitrile. The IUPAC is nomenclature is nitrile, and then the example is propane nitrile. Yeah, CH3, CH2, C triple bond N. Okay, 3 carbon atoms, so propane nitrile. Okay, next we have amine. Alright, amine, the functional group, the structure of the functional group is NH2, and then the name of the functional group is amino. Okay, and the general formula is CnH2n plus 1 NH2, and the nomenclature, IUPAC nomenclature for amine is amine. Yeah, so the nomenclature is ending with the word of amine. Example, we have CH3 NH2, so 1 carbon atom, so the name is methanamine. Okay, methanamine. Okay, so now we look at example. So given a structure of organic compound, so we need to identify the functional group and name the functional group. Okay, so this is C double bond O, OH, so this is carboxyl. C double bond O, OC double bond O, so this is anhydride. Okay, COH, so this is hydroxyl. Okay, and then C double bond O NH2, this is carboxamide. Okay, and then NH2 amino. C double bond C is carbon-carbon double bond, and C double bond O, O is carboalcohol. C. Alright, so this is the example of question how we can naming the functional group and also identify the functional group. Okay, so this is the exercise. Identify the functional group in the following molecules. So given 4 molecules, and then we need to identify the functional group in the compound. Okay, so this is the answer. Okay, for structure for question A. So C double bond C, there is carbon-carbon double bond. Okay, and then B, we have C double bond C, carbon-carbon double bond and hydroxyl. Okay, and then we have for C, we have amino and also carboxyl. Okay, and then D, we have halogen, hydroxyl and benzene ring. Okay, so that's all for subtopic 4.2. Thank you.